Okay, we're about to do problem 3-8 from the Hibbeler statics book, 12th edition. For that, I got a small program I wrote here. Let me bring it up. So for problem 3-8, we're going to enter the information that is given. So we have AB, AC. Okay, so for AC, this is -3 and 4 for the Y. So that would be AC's the green vector here. So now it's facing the right way. And then for AB, it's also given as X and Y. So it's 4 and 4. There you go. Now it's facing the right way. And for the last force, just gonna leave it named AD. It don't really matter. That's 270 degrees from the positive axis, so it's facing this way, and that is given as 300 pounds. 300 pounds. So now we can see the the equations that we need to define the system and to solve for our variables. The first thing you want to do is you want to make sure you know the length of A and C and A and B, which is what we have here. So for AB, we have square root of 4 square plus 4 square. That's equal to 5.65 here. And for vector 2, which would be this vector here, AC, we have -3 square plus 4 square. Square root of that is equal to 5. And then here's just a unit length 1. So we come down here, we have our equations. So you have 4 divided by 5.65 times the force AB plus -3/5 force AC plus the cosine of 270 times 300. That's all the forces in the x direction. And for the y direction, we have 4 divided by 5.65 times the force AB plus 4/5 times force AC plus the sine of 270 times 300, and that should equal to 0. So we have the two unknowns, which is force AB and force AC, and we can put this nicely into a matrix using the coefficients. So for the first equation here, we have 4 divided by 5.65, and we have -3/5. And for the knowns, they're on this other matrix here. We can write them on the other side, and this is basically 0. Negative cosine of 270 times 300. This is going to be 0. And then the second equation here, 4 divided by 5.65 and 4/5, and the knowns are on the other matrix. So the known in this case in the y direction is sine of 270 times 300. It turns into a negative. Here is positive, but when you take it to the other side of the equation, it becomes negative. That's why you see a negative on this for the x and the y here. And so what you do is you take the coefficients of your own knowns, you do the inverse matrix times your knowns here, and you get the equation. You get the resultants, force AB and force AC. This is the fastest way to do it. Just set up your equations and do a matrix and solve them. There's many possibilities, many ways of doing this. Matrix is the fastest way, and you do not have to do a matrix by hand. You can use your TI-89 if you have one, or a TI-89 titanium, your graphing calculator, and what you do is you type this in just like you see it here. You have this bracket here, and you type in the coefficients. So for the first row, for this first matrix, it's 4 divided by 5.65 comma negative 3/5, and then to enter the second row you have to separate it by a semicolon. Then you enter your values, 4 divided by 5.65 comma 4/5, and then you close it, your bracket, and raised, which is a symbol that is available in the TI-89, it's above the division sign, then you use that symbol, and then negative, not minus, -1, so you're raising this first matrix to the -1, then times the second matrix. So the first row of this second matrix is negative cosine of 270 times 300, which is basically, it's 0, so you can put 0 there. And then to enter the second row for this second matrix here, you enter negative sine of 270 times 300, which that should be 300. So when you enter this exactly as you see it here, you enter this into your TI-89. After this last bracket, you press enter. When you press enter, this third matrix shows up, and this represents your unknown force AB and force AC, and that will be your answer. So you can always switch your variables here. So if you put force AC here and decide to go force B here, you can do that, but and these coefficients will be reversed. This one will be here, this one will be here, and so on. So when you get the resultant here, it's just going to be in the reverse. This will be 214, and here this will be 181. But the matrix is the fastest way to do this problem. Thanks for watching, and this is a program that I'm developing to be able to solve this kind of problems. Right now I can only solve for the unknown forces, but I'm trying to get it to where I can solve for angles and distances and all that. But for now, this is just a start. If you guys have any suggestions, I would love to hear them. Thank you. Thanks for watching.